Look around you right now. Your window, your phone screen, the glass and the light bulb above your head if you're indoors. You're surrounded by a material that is, chemically speaking, barely different from ordinary sand. And for most of human history, that transformation, sand into something you can see straight through, was considered close to magic. The real story of how your ancestors figured it out is stranger than any legend attached to it. Picture the ancient world before glass existed as a made material. Humans already knew a version of it. Technically, obsidian, volcanic glass, formed naturally when lava cools fast enough to skip crystallizing into rock. Early humans prized obsidian for its wickedly sharp edges, napping it into blades and arrowheads far sharper than anything stone could offer. But that glass came from a volcano. Nobody was making it on purpose. Nobody had figured out how to start with plain sand and end up with something a fire hadn't already finished for them. So how do you go from admiring a volcano's leftovers to deliberately manufacturing the same material at will? Here's the detail that reframes the whole question. Glass wasn't invented by someone trying to make glass. It was very likely discovered by accident, by people who were trying to make something else entirely. Around 5,000 years ago, in Mesopotamia and Egypt, artisans were already working with a material called Faience, a bright blue-green ceramic-like substance made by coating crushed quartz sand with a mineral glaze and firing it at high heat. Faience wasn't glass. It was closer to a glazed pottery bead, decorative, valuable, used in jewelry and small ornaments. But the chemistry involved, heating sand mixed with certain minerals to extreme temperatures, was accidentally rehearsing the exact recipe glass would eventually require. This is where researcher Andrew Shortland, an archaeologist at Cranfield University who has spent years analyzing the chemical composition of ancient faience and glass, enters the story. Shortland's research on Egyptian and Mesopotamian material suggests that early glassmakers weren't chasing transparency at all. They were chasing color. Ancient glassmaking workshops from this period produced almost exclusively opaque, richly colored glass, deep blues, reds, and yellows, meant to imitate precious stones like lapis lazuli and turquoise that were expensive and difficult to acquire through trade. Glass, in its earliest form, wasn't a window material. It was a stone substitute, a way to fake a gem convincingly enough that almost nobody could tell the difference. Shortland's chemical analysis has traced specific glass workshops by their cobalt signatures, tiny trace element fingerprints left behind by the exact mineral source used to create that particular shade of blue. That level of detail matters enormously because it shows these workshops weren't randomly stumbling onto colors. They were sourcing specific pigments deliberately, from specific mines, refining their formulas over generations, the same way a modern manufacturer might guard a proprietary dye recipe. This was a genuine craft industry, with specialists who understood their materials far more precisely than the phrase ancient artisan tends to suggest. Think about what that means. The thing you now barely notice, the clear pane between you and the outside world, started its existence as ancient counterfeit jewelry. There's a persistent legend, recorded by the Roman writer Pliny the Elder, claiming that Phoenician sailors accidentally invented glass by resting cooking pots on blocks of natron, a natural soda ash mineral, on a sandy beach and watching a mysterious liquid form as their fire burned through the night. It's a wonderful story. Most archaeologists and historians now treat it as exactly that, a story, since a campfire simply doesn't reach the roughly 1600 degrees Celsius required to properly melt silica sand into glass. The real invention almost certainly happened in a controlled setting, inside specialized kilns capable of sustaining much higher, much more carefully managed heat, developed by artisans who were already skilled furnace operators from years of firing ceramics and metals. So if it wasn't a beach campfire, what did it actually take? This is where the science gets genuinely demanding. Pure silica sand melts at an extremely high temperature, difficult for ancient furnace technology to sustain reliably. Early glassmakers discovered, likely through the same trial and error process that shaped early metallurgy, that adding natron or plant ash, both rich in sodium, dramatically lowered the melting point, making the process achievable with the kiln technology already available for firing ceramics and smelting metal. Add lime, often introduced accidentally through impurities in the sand itself, and the resulting glass gained durability, instead of dissolving back into a chalky mess the first time it got wet. This exact combination, silica, soda, and lime, remains, remarkably, the basic recipe for most glass manufactured on Earth today. Nobody in ancient Mesopotamia understood molecular structure or amorphous solids. What they had was patient, repeated observation. This batch cracked, that batch stayed clear, this ratio worked, that one didn't, passed down as closely guarded workshop knowledge from one generation of artisans to the next. Consider what running one of these early furnaces actually demanded. Someone had to source enormous quantities of fine sand, ideally low in the kind of impurities that would ruin a batch. Someone had to gather and process plant ash or mined natron in exact, repeatable proportions, since too little wouldn't lower the melting point enough, and too much could make the finished glass unstable and prone to slowly dissolving in humid air over years, a defect ancient glassworkers referred to, in various languages, with words that essentially meant glass disease. Someone had to feed a kiln fuel continuously for hours to reach and hold a temperature no cooking fire could approach. This was not a hobby. It was an industrial process run by specialists in an era most people imagine as having no industry at all. For roughly 2,000 years after its discovery, glass remained a luxury reserved for the wealthy and powerful. Every single piece had to be core form, a slow, labor-intensive technique where molten glass was wound or dipped around a solid core, typically made of clay and dung mixed together, shaped roughly into the desired vessel form. Once the glass cooled, artisans painstakingly scraped the core material out from the inside, leaving a small, thick-walled container behind. It was slow, it was expensive, and it meant that owning a glass cup or bottle was a genuine status symbol, on par with owning fine gold jewelry. Here's the twist that changes everything. The moment glass stopped being a rich person's trinket and became something ordinary people could actually own. Sometime around the 1st century BCE, in the region of Roman Syria, an unknown craftsperson discovered that a molten blob of glass on the end of a hollow tube could be inflated, like a soap bubble, into a hollow vessel almost instantly. Glassblowing. This one technical shift changed everything about how glass could be produced. A skilled glassblower using this new technique could produce dozens of vessels in the time core forming used to take for one. Glass didn't just become cheaper, it became fast, and speed changes economics in ways that ripple outward for centuries. Researcher Julian Henderson, an archaeologist at the University of Nottingham who specializes in the chemical analysis of ancient glass, has spent years tracing how glass-blowing technology and glass composition spread across the Roman world through careful chemical fingerprinting of surviving artifacts. His research shows glass production exploding in scale and geographic reach within just a few generations of glassblowing's invention, moving from a rare specialist's craft into something resembling early industrial manufacturing, with major production centers supplying entire regions of the empire. Suddenly, ordinary Roman households could afford glass drinking cups, storage jars, and window panes, objects that would have been unthinkably expensive luxury items just a century earlier. Glass windows began appearing in bathhouses and villas, not because anyone had figured out how to make large, perfectly flat sheets yet. That technology was still centuries away, but because even small, slightly uneven, blown glass panes let in daylight while keeping out weather, which was, for the first time in human history, an option available to people who weren't royalty. Roman glassblowers also discovered something almost as consequential as the technique itself: recycling. Broken or unwanted glass, called cullet, could simply be remelted and reused, since glass, unlike many other materials, doesn't meaningfully degrade when heated again. Archaeological sites across the former empire have turned up sacks and bins of collected broken glass, clearly gathered specifically for resale back to workshops. That single practical insight, that glass could be endlessly reheated and reshaped without losing its basic properties, quietly anticipated an idea that wouldn't become an environmental talking point again for roughly 2,000 years. Think about the strange symmetry sitting underneath this entire story. Glass began as a deliberate imitation of precious stone, a way to fake something valuable using cheaper, more available materials, and it ended up becoming genuinely, independently valuable on its own terms, valuable enough that we stopped thinking of it as a substitute for anything at all. Nobody today buys a drinking glass because they wish it were a sapphire. That transformation, from counterfeit gem to indispensable, unremarkable material, happened slowly, across thousands of years, driven by furnace operators chasing better color, metallurgists chasing lower melting points, and one anonymous craftsperson in Roman Syria who tried blowing air into a molten blob just to see what would happen. Look around you right now. Your window, your phone screen, the glass in whatever light source is nearest to you. Every piece of it traces back through that same long chain. Color-obsessed Egyptian artisans, patient trial-and-error metallurgists, and a single unrecorded moment when someone picked up a hollow tube and decided to blow into it instead of just shaping the glass by hand. It's still, chemically, barely more than sand. It just took your ancestors about 5,000 years of stubborn experimentation to notice.